morning, y'all. My name is Jeremy Abbott, and if you're here to listen to Currying in a Hurry or Intro to F#. There's a few reasons for this title. One of them is the call for speakers said something creative, and this is as creative as I could get for a title. So that's the background on that, but y'all find out it actually has some functional meaning in this functional programming talk. So who here has ever used F# before? Negative. So who is familiar with functional programming at all or remembers it from college? That's more than me. When I started learning F#, everyone was like, oh, well, that's just like Lisp, right? And I've forgotten about Lisp. Like, I remember doing it in college after somebody said that, but before that, I didn't remember it. I took the fun route through college, so I don't remember it. Or the wrong kind of fun route. But anyway, so like I said, my name is Jeremy. I'm on Twitter, Mr. J Abbott. You can email me, or I have a blog, but there's not a lot going on right now. Maybe after this talk, I'll put some stuff up there. I'm not the figure skater. There's a figure skater named Jeremy Abbott. He was in the Olympics in 2012. My aunt wrote me on Facebook and said, hey, I didn't know you skated. I'm not kidding. And I was like, no, I totally don't skate. So I actually follow him on Twitter, and that confuses me sometimes because I'm like, I'm not doing this right now. What's going on? And so, yeah, I'm not the figure skater. So a lot of times there's a lot of more introductory stuff about me. I don't want to do that because this is a really dense talk. This is an intro to like F#, so it's pretty basic, but there's a lot of basics to get through. And I'm hoping that when I'm done, y'all will feel more comfortable going to one of the 2 F# talks after this one. I'm excited about that. I'm glad the schedule worked out that way because I hope I give you the information you need to feel more comfortable in the next one. So a few other housekeeping things. Thank you to Paul for organizing Code on the Beach. This has been a lot of fun so far. And thank you guys for being here at 8 o'clock in the morning. I know that's not everybody's cup of tea or coffee. Thank you to Al and Stacy, our keynote speakers for the last 2 days. I really enjoyed their talks and the perspectives they give on the industry and what they do. I'm going to steal something that Stacy said yesterday that was kind of cool. I appreciated it. If you know more than me, feel free to correct me after, unless you're one of the 2 F# guys in here and you're worried that I'm going to derail their learning. Please stop me and say, no, that's not right. But other than that, I'll help you keep the flow. There's a lot to cover. And with that being said, questions are totally welcome. If there's something that you want to talk about as it relates to C#, please ask me. That'll help you all with the process. And there is a ton to cover, so I'm going to get through as much as possible. I might finish. Depends on how many questions there are. But let's get started. So what is functional programming? I'm just going to read this and then no more reading. Functional programming treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. That is a mouthful. There's a lot of math concepts in functional programming, but you can kind of get your feet wet in it and be really productive without worrying too much about all the mathematical symbols and lambda calculus and all that good stuff. We're only going to talk about 1 or 2 really basic math things today, and that's more just because that's the idiomatic way to describe what Visual Studio tells you. But other than that, we're not going to jump into too much math, so yay for that. But when we say functional, we don't mean like a JavaScript function per se. We are talking more like functional, like f of x equals x plus 2. If we pass something in, we're going to get the same thing, that something in, we're going to get that same something out every time. And that's like a rule that will never change. Like if I pass in 2, I will get 4 back, and no matter where I am, that will always be 4. So that's kind of what we're talking about when we say functional. A given input will always have the same output, and f of x is immutable. It does not change. So just what I just said. If I put in 2, I'll always get out 4. There's nothing about that will ever change. And that's immutable. Immutability is a big deal. We're going to hear it a lot. So let's talk about F#. Most of y'all said you've never worked with it. F# is a cross-platform, functional-first, multi-paradigm programming language. All that means is I can write F# code in a fully functional way, or I can do some like object-oriented programming, and I can do this on Mono on Linux and Mac, or I can do this on the core.NET CLR on Windows, and soon to be actual open source Microsoft CLR on Windows and Linux someday soon. It's statically typed, and that's going to surprise y'all when you start seeing code because you're not going to see a lot of types in my declared explicitly. It's just sort of going to flow through there. And we're going to talk about why that is and how that works and how you can be more explicit when you need to be. Let's see. Created by somebody named Don Syme, who's very nice. You can talk to him on Twitter. He's a Microsoft researcher, a principal developer. If you love .NET generics, and that's one of the greatest things about .NET, he's a big part of why that's there. So give him a shout. And one other thing that you guys probably don't know, and I didn't know until I started learning this, the syntax derives from OCaml, so you might see if you just sort of Google some functional programming information in general and not necessarily F# specific, you'll see some syntax that looks like F# and it might be OCaml just in a generic programming sense. It's a pretty common syntax for the paradigm. So why would we want to do functional programming, or why F#? Default immutability limits side effects, and we're going to see what that looks like, but the idea is once I declare a value, I'm not going to be able to change it later, so I know that it will always be that thing. It makes testing really interesting and really easy. The syntax is really terse, and it makes my code a little cleaner, a little easier to read. The F# community is really nice. On Twitter, if you hashtag F#, the people will help you out. There's some really good conversation. They're really funny. And F# has a REPL, read, evaluate, print loop, so we can do some interactive programming, and we're going to do some of that today. Not a whole lot, but I'll show you how to get started with it, and you can do some pretty cool stuff with that just through the command line, really. All right. Here's some rules that we're going to follow for the rest of the talk. Default immutability, it keeps coming back. Everything is immutable by default. I said it once, and it's not going to change after that, except for the one time when I show you how to make it immutable, and then we'll never do it again. Everything is an expression that returns a value, even if that something is nothing we care about. That's kind of weird. We'll talk about what that means, but everything in F# is an expression ultimately. Functions always accept an input and always return something. Again, even if that input or output isn't something we care about. White space is significant. You're not going to see like a big in or end, and you're not going to see any curly braces, at least not as it defines a code block. A code block is defined by the code that is dependent on that block being indented after the first line. File order matters, and I'll show you what that looks like too. And last but not least, F# in the wild. You may be using F# but not really like doing a lot of super functional stuff with it yet. If you've tried Fake, which I highly recommend for all of like your build scripts. It has great interoperability with TeamCity and other build tools, and also has some interoperability with Octopus Deploy. Anybody use that? If you don't use it, I highly recommend it. It's the most amazing deployment tool ever. It's changed our life. We went from deploying like every other day, maybe, to every day, no questions asked, and it's pretty painless. I love it. And that's a whole different talk that I could give if we needed to. So yeah, let's see some F#. And I'm going to be going, there's not a whole lot of slides. There's slides for every piece of code, but I'm going to stick in the code for the most part. But let's talk about some F#. I could do hello world, it's not great. One thing that's cool about these slides though, by the way, if I mouse over it, it gives you IntelliSense. I'm using something called FS Reveal, which is a open source project for writing your slides in F#. It compiles it down to Reveal.js, if anybody's familiar with that. So yeah, all of the slides in here, if you want to look at them later, will have the IntelliSense, but we're going to look at some real code instead. So something a little more practical. Totally going to scare you guys. Not really, though. We're going to talk about a self-hosted web API written in F#, and I think most of us are familiar with web API. Raise your hand if you're not. No, most of it. Web API is pretty awesome. It's one of the best things .NET's done in a while. I use it at work every day. It's my favorite thing ever, and I have a rule that anytime I use web API, I try to avoid having system.web anywhere in there if at all possible, because web form's bad. Everything else after that is better. So yeah, this is a self-hosted web API written in F#. And before I zoom in, let's talk about, we had mentioned terse syntax, terse syntax. So I did this in 38 lines of code, all in one file. And it would have been a little bit shorter, but I put in some fun attributes and some comments that I needed just to help you guys and help me. So we're going to go from the top down and just sort of talk about what this is. And I only do that for this part of the talk. If you really want to learn F#, try to embrace it from a functional aspect and avoid the OO parts, because those will keep you from really learning some of the functional concepts. So I'm doing it here just so you guys can see this is totally .NET. I can use everything in .NET and some of those parallels, but after that, it's going to be strictly functional. So again, if you have any questions, let me know, but otherwise, we're going to deep dive into this. So the first things y'all are going to see are open statements. Those are basically your using statements. I'm opening a namespace so I can use the goodies inside. Got to have a reference in the project for it. Totally have a project still. Can y'all see this if I don't zoom in? Cool, all right, so this is my very first function that y'all are going to see. Notice there are no types defined. It's not public or private or anything. And if I mouse over it, it's going to say that it accepts 2 strings and returns a string, and we'll talk about what that syntax means. But that's me writing a function to format a URL using the base and the endpoint. And then I have my first attribute, which literally does nothing other than be funny. There's a guy in Australia who created this library called Disappointingly Attributed. And one of the cool things it shows, though, is I can create a variable, or I'm sorry, a value, that has non-traditional characters in it for the variable name. So I can say, like, hello world is as the name of this equals, and that's totally valid. I'm just using backticks, and so now if I use this anywhere else, I'm going to get a string of hello world. So that's something you can do in F#. I don't do it a whole lot, but there's some use cases. If you start using type providers, there's a couple of use cases for that, and we might get type providers today, probably not. But yeah, so that's a thing. Also, I think that flipping tables is funny, especially at 8 o'clock in the morning. So yeah. Anybody, so if you're not familiar with Owen, which is the self-hosting tool we're using, you have to have a startup class. This is it. This is a class, public class, startup. And it is going to have one method on it, and it's the configuration method, which accepts app builder and returns void. That's sort of a condition of Owen. You have to have a startup method. You have to have a configuration method in a startup class that, by convention, Owen knows to use to configure the application before we run it. So that's what this is, and I did it in a very few, or like 5 lines of code, 6 lines of code. So this looks just like any other web API you've configured, though, right? I have a config object. I have to set up a default route. I'm going to set some optional parameters on that route, and then I'm going to pass that to that configuration to my app builder object that was passed in. And I'm also, because this has to be void, and everything in F# is an expression, the last expression to be evaluated is actually what gets returned. And we're going to break all this down. I want this to be a void method, though, so I'm going to ignore the output. And we're going to actually write our own ignore function in a second. It's really easy. So yeah, that's my startup class with a method in 6 lines of code. And then I have a controller in 4 lines of code with a single action. And I inherit from API controller, like I would if I was doing an API controller. And it returns an enumerable of strings, or really an array of strings, but enumerable. Also note that my values are delimited by a semicolon. If you put a comma in there, you're going to be really sad later. And we'll talk about why that is. And then finally, my main method. So if this was a console application in C#, I would have like my public static main inside of program.cs. And this is sort of the same idea here. I have a function that's called main. It accepts an array of arguments, and I'm going to do some stuff with it. We have another attribute here. Y'all noticed we have like square brackets and then angle brackets. That's an F# thing for our attributes. And in here, we declare a value for the base address, so we're on port 9000. We have a different kind of binding. So like to this point, if I was creating a variable called a value, I've been using let, which says let's bind this thing to this name. So the name of base address has a value of HTTP localhost 9000. There's another type of binding called use. And knowing if you guys have done this before, like a console-based web API, just as an example, what might use be that's different from a let binding? Thank you. Yeah, so this is like using using to instantiate a disposable and then kill it as soon as we break out of that scope. Same thing happens here. As soon as I break out of this function, these get disposed. So that's how use works. And instead of doing it in like 3 lines, I did it in 1. So that's kind of cool. But I still know exactly what's going on. Like you can infer from the usage what it's actually doing. So finally, I knew up a couple. I knew up my HTTP client, and I make a request. Most of this after that looks pretty much like you would do it in C#. And again, they're interoperable. So let's run it. And yay, I get my 2 responses printed to the command line. Super, super useful. We can ship it. But yeah, that's real hello world F# style. And let's get back to the slides. I love how terse that is, but you can still totally see what's going on. I have all these types declared in a single file, and I'm getting my job done. Anybody can come in there and see what's going on. It's awesome. So yeah, let's go back. So let's talk about immutable and mutable, because that's going to be a big concept going forward. Immutable, unchangeable over time or unable to be changed. So, and then there's mutable, which is the opposite of that. For example, you guys are using immutable data types all the time. Most of you, I'm sure, know this already. Strings are immutable, except when they're not. And you can do some really weird stuff, like using some C# way under the hood to mutate an actual string. I learned this the other day. I wish I could find the link again. It's really weird. But yeah, in general, if I try to change the string, like concatenate to it, I can actually get a pointer to another reference, another spot in memory for that new string. The old string is still whatever it was. You can kind of get immutability in C# using like the constant read-only keywords. So yeah, immutable by default. If I have a value of x and it's set to 2, and I try to set it to 3 later, this actually is not the assignment operator after the initial binding. And what comes back here is an expression that says, no, this is not 3, that's false. So I have a Boolean expression. That's fun. And I get true if I compare it to 2. So I actually want to talk about that a little bit more did I miss something here? No, okay. Talk about that in F# Interactive, which is pretty cool. So F# Interactive is already installed in Visual Studio by default. There's not a whole lot you have to do with that. If I want to get to it, I can go to View, Other Windows, F# Interactive, or I can do Control-Alt-F. And what that gives me is my REPL, my read, evaluate, print loop. So I can go in here and do kind of what we just did. I can start just writing some F#. So let x equals 2. And can you all see that? Awesome. All right. It's going to say x is 2. If I want to terminate my line, I have to do double semicolon, just heads up. So now I want to say x is equal to 3. It's not. So let's talk about assignment, though. What if I actually wanted to try to change this to 3? I use this assignment operator, less than dash, or the left arrow, yeah, equals to 3. And what happens? I can't do that because this value is not mutable, because immutable by default. Now, let's say I wanted it to be mutable. Let mutable y equal to. All right, now I have a mutable value. So anytime I want something to be mutable, I have to do that explicitly, immutable by default. But now I want to say y equals 3. And that still false because, again, the equal sign is not for assignment after the initial binding. But I want to make y 3 for real. Cool. So now y equal to 3 is true. That is mutable, immutable. And I can show you some more over here. It's the same example. All of this code, by the way, is going to be on GitHub already. I have some links at the end of the slides here, and I'm going to tweet them out later. We don't need those yet. Cool. So that's F# Interactive. You can do way more constructive things with it for exploratory programming, but that's part of it. So yeah, let's talk a little bit more about functional for a second, and then we'll get back into the code. Like I said, f of x equals x plus 2 is kind of what we're talking about when we say functional. It's a function that adds 2 to the input of x. X is my domain, so that's like the input I'm passing in is my domain. The range was my output, and it's going to be the value of x plus 2. And what we say is this function maps x to x plus 2. Functions accept exactly one input, and we're going to talk about this more later because you've already seen a function, my format URL function accepted 2 arguments. So what does that mean? We're going to see. So here is an F# example that's super complicated, you guys. We're going to add 2, and now we can kind of talk about that syntax a little bit that y'all see. So we have like x is an integer that goes to integer. That's what when I see that little arrow, that's what that means. Another way of saying that is add 2 is a value that maps x to an integer, another integer. So that's my domain and my range. So I have a function named add2, which maps an int to an int. No matter what happens elsewhere in the world, and that's mostly true, this function will always return the same output for a given input. And when I say mostly true, if you have like some global state that you're encapsulating in your function, yeah, you're going to get exactly what you'd get in an object-oriented program. And that is something that where the output is conditional on state that you don't really have any control over somewhere else. Hopefully it's immutable state, so you're kind of sure that's not going to change. But if someone adds mutable, you've lost the benefits of your functional programming. But yeah, in general, if I pass in 2, I'm going to get 4, unless I do something weird. Bindings and values, I don't want to hit on this too much, but the let binding is how I bind something to a name or a symbol effectively. Lambda calculus is all about functions and binding them to symbols, and so that's what we're doing here. Values are not variables, and the main reason for that is kind of obvious. Variables imply that they are varied and can change, and these do not change. All right, let's see. Functions are also values. I can pass a function around just like I can pass around any other type, and which isn't that different from what we see like in later C#. What you're going to start seeing is as C# evolves, it just becomes F# with more stuff as far as like angle brackets and noise. And I don't mean that in a bad way. I actually love C#. That's what I use in my day job. F#'s my hobby. But like they're talking about in C#7 having pattern matching, which we're going to talk about. That came directly from here. And functional programming in general. But like if you see like some functions, especially in LINQ, or methods like in LINQ, where it expects some sort of anonymous function, that's you passing a function, and it can be a named function somewhere else as long as it matches that signature. And that's kind of what we're doing here, except with a lot less noise behind it. So yeah, functions are just values. All right, so now we're going to talk about, when I say statically typed, and we haven't really seen any types yet, what that actually means. F# is evaluated from the top down, and so that has a couple of consequences. I want to show you what that really means, though. So if I go into here, well, and by here I mean all of this code. I'm going to comment all of this out or open up a module. Open, let's see, what are their names? Sure, functions. All right, I go in here. Let's say, well, we're going to use add2. All right, cool. Well, first of all, let's move this down. Totally going to break my code. And go back to programs. So what I just did here, by the way, was, like I said, file order matters. This position is actually preserved in my fsproj file. So like just like you have a csproj file, I have an fsproj file. It's my F# project. And the order of the files in there are important for the compiler. So what basically that means is if I have a file that's being used somewhere else in the program, the file needs to be before that. So right now I just opened up the functions module inside of program.fs, and it's not going to like that. So let's go back to program. And yeah, it has no idea what I'm talking about. It says the namespace is not defined. That's because it's after it. The compiler has no idea that exists yet. If I move it back up, and I could do this through the context menu or Alt up arrow, and I come back in here to the right one, and make sure first off that I named it right.
It's not the naming, it's the file.
Is it? Did I mess it up? Oh, my bad. You're right. Thank you. Yeah, that was an actual F# file, so let's do, yeah, that's an F# script file. Let's add a new one real fast. Thank you for that. Source file, cool. Oops. Awesome. Okay, oops. This is a function that returns a string, and its location is at the end. So now if I open that up, oops, I'm going to get the same thing. Oops is not defined, and I can move that up. And we're OK now. Oops totally exists, and I can start using things inside that module. That's what I talk about when I say file order matters. And thank you for your help. I appreciate that. I would have done that for a long time. So what that means, though, because of like the way the compiler works and it's in a top-down approach, the compiler can make some assumptions about what my code is, and that's where type inference comes in. I can say that I know what the inputs and outputs are of a function based on how they're used instead of having to make those types explicitly. In this case, like this function is going to accept two yeah. Actually, I totally broke that code sample. Those X and Y should not be there. But in general, it's going to say, I know I'm returning a string even though I never really said anything about strings, just based on what's going on inside the function. So in this case, I have like a string format function is the only expression in it. So the return type is string. Cool. All right, so white space is significant. Y'all kind of already saw that. And like even in here, everything that was inside of a block was indented. It's indented with spaces, not tabs, boot tabs, which is good for y'all because Visual Studio by default is space delimited, not tab delimited. You can change that, but then if you write F#, you'll be really sad. Don't do that. All right, so yeah, that's basically type inference in a nutshell, but let's look at some more examples because why not? And I moved all my stuff around. Where did I put it? Functions. That's not it. F#. Maybe I don't have them. No, well, it's fine. We'll come back to it. All right, so we're going to break this down a little bit. In this case, yeah, I have a function that just is basically returning a formatted string for me, which is already built into the F#, so I don't need to do this per se. And there's a better way to write this, which I was trying to do earlier and I messed it up. But in general, without ever saying X and Y are strings, what I'm getting back, it knows that they have to be strings. I can actually pull this into F# interactive. Let's see. Paste. And I can totally start using this. And I can pass in something that maybe is not a string, like 1, 2. And it's going to say, hey, I'm expecting strings, but I got integers. And again, I didn't set my types explicitly. That's the key here. So this is the type annotated version of the previous example. And when I say type annotation, this is when I explicitly set my types. I'm saying that this accepts strings. So it's the exact same function, but I'm saying X is a string and Y is a string, and I'm returning a string. Yeah, I need to have a semicolon there. Or not semicolon, a colon. I noticed that too. Thank you. The other thing to point out here is, like I said before, everything's mutable or immutable by default. So I'm using a let binding up here for this function. I can't exactly like create an overloaded function or overloaded method, if you will. That would change the state of that name. So I have to use this little tick mark to say this is kind of like an overload that I want to use, and it's really not in this case, and which is another reason why it's not overloading is kind of weird in this context. But if I wanted to do something with the same method name, function name, I can't. But yeah, to emphasize here, this should totally be a colon right there, indicating that like that last type is the return type. All right, cool. So now we get to like why I call this currying in a hurry, besides the fact that the call for speakers said a creative name and I'm not super creative. Currying is the idea that we're going to take a function that says it accepts multiple arguments and break that down into multiple functions that all accept one argument and evaluate accordingly. And we're going to go through a ton of examples of this, so don't feel kind of overwhelmed right now. Functions accept exactly one input. This is more than one input, right? The compiler reads this as x is a string. X is a string that goes to y is a string, and it returns at last a string. Or x goes to y goes to string. X maps onto y, which maps onto a string, which we already talked about. The F# compiler rewrites functions with multiple inputs into individual functions that accept one parameter. This is called currying and is named after a Haskell curry. Haskell is also a functional programming language. So now you know why it's called currying in a hurry and why and where Haskell comes from if you didn't already know that. But let's talk about currying a little bit. So yeah, I have this function that I keep coming back to, and it's let's say something short, and it accepts 2 arguments, but it really doesn't. What happens under the hood is it's going to create a function that accepts 1 argument, and it really is going to either do one of 2 things at this point. If I passed in 2 arguments, it's going to return and evaluate a function that accepts the other argument and then evaluates it, or evaluates it, yeah, creates it and then evaluates it. Or, and what we'll talk about later, I can actually pass in just 1 argument and get a function back that accepts the other argument. Yeah, so that's kind of crazy, but here's the thing. These are functionally equivalent. I almost hate saying that, but haha. What I'm doing here is, if I were to call this, and I can totally put this in FSI, it's going to do what we've seen in other cases, which is to say something short tick, hello world. Even though it looks like the signature says I'm taking 1 argument, I'm taking 2, and I'm going to get back a string that says hello world. And what's happening there is this is an anonymous function that accepts an argument of y, and then it's going to evaluate or format those inside of here and return it. So what you can kind of see here is like this x is almost in a closure at this point, and I have another function that's going to use that x and along with the other argument of y right here to do some work. And this happens no matter how many arguments there are. The compiler is going to break all this down into multiple smaller functions, all accepting a single argument to give us ultimately our output. And I mentioned this a little bit earlier. I could actually write a just call, let's say, something short, and I might do that now, and only give it 1 argument. And that's totally valid, totally valid. And instead of getting an error, I get back a new function that accepts a string and returns a string. So, like I said before, currying's about turning a function that accepts multiple arguments into multiple functions that all accept a single argument. Partial application is kind of the other side of that, where I can pass in only some of the arguments and get back a function that accepts the other parts of the arguments. And this is a really key part of functional programming and F# in general. And you're kind of already using it in C# if you're familiar with like LINQ, except that not the partial application part, but the idea of passing in functions. And we're going to talk about higher order functions in a minute. And you're going to see some very LINQ-like things. And this will hopefully click for you a little bit then. But the idea behind partial application is only supply some of the arguments to a function, and we'll get back that function, and then we can use that function somewhere else. So like maybe I have like a filter function, and I want to filter off something. I should turn that off. Sorry, guys. Somebody wants a link to the slides, which they're going to get. Awesome. But yeah, so I can like pass in some of the arguments to that function and create a more specific version of that function that does something. Like in a filter context, let's say I want to filter by name. And I have I can pass in the name and say, let's filter by Jeremy, and I'll get back a function. I'll get back a function that just needs an array to do the filtering and return everybody whose name is Jeremy, something like that. And I'm going to show you that exact example actually. What else we got here? So let's go look at this one real fast, and we'll go into code. So yeah, I want to say hello to somebody. I can say I can take my say something short, pass in hello, and I'm going to get back a function that accepts a single string. And in this case, that single string is world, and I can say hello to world. And one of the cool things about this, there's two things to take away. One, I can make new functions that are very specific to like my purpose. The other thing is I can make functions that are really reading like English with using this partial application idea. So they're very specific, they're very domain oriented, and I can kind of reason about what's happening in a fairly simple way. And again, all I did was I only passed in one of the arguments. I passed in the first argument and not the second one. So I get back a function that's waiting for that second argument. And if I had a function that took 4 arguments and I passed in 2, the first 2, I would get back a function that was expecting the second 2, or really 2 functions that accept 1 argument each. But you don't have to think about that too much. Just know that you can do this type of stuff. Let's see what else we got. So let's go look at some actual more better, that's nice, some better examples. And we're going to go to functions. I don't know what I broke over here, but that's okay. Whatever, I'll deal with that later. We don't need it anymore. Partial application and currying, cool. So y'all have seen most of this already. I don't need to go through that. But there's some more interesting examples. Yeah, like so format URL is a function that accepts 2 strings. And what actually is happening here, I'm using that idea of partial application. This is a built-in F# function, if you will, and this syntax effectively says I'm formatting 2 strings and I'm separating them with a slash, but I didn't pass in the 2 strings. So what that means is I partially applied this function by not really applying it at all. So I get a function that accepts 2 strings called format URL, and it has in its signature string goes to string goes to string. And you guys saw that in my first example where I'm passing in the base URL and my endpoint. But again, I have like a name that's very semantic to its purpose using this idea of partial application. But here's something a little more practical. I have a filter function that I'm going to use to filter stuff by name. Specifically, I'm going to filter arrays. And so array.filter accepts a couple of things. It accepts a predicate and finally an array. So what I'm doing here is I'm actually passing in that predicate, which is an anonymous function. It returns a Boolean for every item in there, and it's going to give me like a subset of those based on that, what it evaluates. And one thing to note, obviously, or maybe not quite obvious, is that this is not changing what array I pass in. It's giving me a new one because immutable. So yeah, what I end up getting though is a function here that is going to accept a name and an array and do something with those. So this is kind of a complex example because not only am I getting a function back, I'm also getting a function back that accepts a name that I defined here. So I'm combining the idea of passing in an argument and also partially applying a function. And so if I wanted to actually use that though, I come down here, I can actually create another function partially applying that. I want to filter by Jane. I don't know why Jane, that's just who I picked. Down here, I partially applied that function again, so now it only accepts an array. Okay? So if we keep going now, we can say if we filter by name, Jane, and then the array, I will get back just an array with Jane in it, an array with 1 item. So yeah, array.filter accepts a predicate and an array and does something with it on each item and returns that array where each item in it evaluates to true. And at this point, I haven't given it an array yet, and it doesn't know what name is, so what's going to come back at this point is a function that accepts a name and an array. And if you actually look at the signature, it's a little less obvious what's happening. This is a generic. Actually, it doesn't really know, and it could be anything that we're filtering by. So at this point, it doesn't care if name's a string or if name is any other thing. We're just checking for equality on types. So this tick A is kind of how F# talks about generics. It's not, instead of the big T that we're used to seeing or like whatever, it's a tick and then an A. And if there were multiple generics, it would be like tick B, tick C, and so on and so forth. I haven't tried it with 27 generics to see what would happen.
Do the ticks balance out the number of bugs you would get writing this in C#?
I'm sorry?
Do the ticks balance out the number of bugs you would get writing this in C#?
I don't know what the ticks are actually for, to be perfectly honest. Anybody want to say why we do ticks? If the ticks would prevent bugs, or can you repeat that? Oh, you're saying why it is.
As in the ticks balance.
Oh, they balance out the number of bugs. I'm sorry, I'm totally not in pun mode this morning. It's too early. Nice. So yeah, that's the symbol for a generic, and what we're saying is we're going to take it a generic of type A, and also a function that is an array of type A that accepts an array of type A and returns an array of type A. So yeah, what it's saying is I can do this with any sort of type, and it's not specific. But again, I didn't have to define anything, which is kind of awesome. That's my type inference working for me. I wrote this a couple different ways though, so I can say filter by name, pass in the name, and then the array. Or another way of doing it is what we call piping, and I can take the array of Dick and Jane and pipe it as the last argument to this expression, filter by name, Jane. So the last argument here is an array, and what I'm saying is let's take this and we're going to push it forward to the last argument here and get the result back. The piping is used quite a bit in F#, and like the front of my slide and my T-shirt both say, this is the F# logo, and it's actually the pipes left and right, which I didn't see right away until I got an explanation for the logo. But that's what that's all about. Piping's a big deal. And it's kind of linky. I don't know if that's a word, but we're making it one today. Linky as in L-I-N-Q-Y. So if I go in here, and this is another example, I have two functions that I wrote. IsFactor accepts the factor and the thing to test to see if this is the factor of. And I can say, and I can partially apply it, and I can just say, is it even? So anything that's a factor of 2 is going to be even. So at this point, it's accepting just that thing that we want to evaluate, right? I got a function back that accepts that x, and int goes to bool. So I'll say true or false. So now I can take like an array of, well, let's step back a second. So last but not least, I have a function that's going to get the sum of everything that's even in an array of numbers, or really integers, but whatever. And it's going to take those arguments, it's going to pipe them to array.filter using this predicate of is even. So the last argument here is that args array of ints. And then it's going to take the result of that evaluation and pipe that in to array.sum, which has a single argument, which is an array of, in this case, integers. So that's piping working for you. And when it's all said and done, though, sum of evens is just accepting an array of integers. And so I can create that array using this cool syntax, 1.100. I get an array of 1 to 100. And if I pass it to sum of evens, I'm going to get a sum of 2 through 100. So yeah, that's partial application incurring, maybe too long-winded, I don't know. Hope you guys, does that make sense to everybody? Cool. So what else are we going to talk about? Also, we got piping, we're good. So we're going to talk about F# types. We're really talking about functional types at this point, but we're going to take a little detour to talk about unit, which is kind of like C# void. I don't like to call it that because it has a slightly different meaning. It's a return. It means we're returning something that we don't really care about. Everything in F# is ultimately is going to evaluate to something, and it might be something we don't care about. So what that means in practice is what you guys saw in my in program.fs at the last bit here. Not quite the last bit, maybe up top. I thought I had an ignore in here. Ignore. Cool. In this case, even, I don't want to get an instance of @builder back. I want to get back void, or the compiler is going to treat this as void. So we're returning unit. But we're going to talk about it some more. So the unit type is actually represented by open and close parentheses, which is kind of weird, and we're going to see what that really means. If I want to define a function that doesn't accept any arguments but does some work, I would say the function name unit equals, and so it kind of looks like a function definition somewhere else that doesn't accept any arguments with that open and close parentheses, but doesn't quite mean the same thing because it's actually an input to that function. And hopefully I do have an example of that. So like say hello world. This is actually an input to that function, and the output of this function is also unit. So if I mouse over this, unit goes to unit. So the domain is unit, and the range is unit. It's actually treated as a type in most respects. I can't do like unit.toString. It's not an object. It's more like a value type. But except you can do toString on integers, so never mind. Yeah, but you cannot do, it's a weird thing, but it represents the fact that we don't care about what that output is, and there is no input, or no input that we care about. All right, let's talk about some more interesting functional types. Tuples are the most basic functional type, and there's a few things we can talk about with that. We're grouping values in a single immutable construct that's not labeled. We only know about it by position. So it's useful in limited context, but once you start getting like a lot of arguments, it's more appropriate to use something that has names so that we don't forget what we're actually working on. But there's a few things to talk about with tuples. When you mouse over a tuple, you're going to see like string times int times float. What a tuple is from a math standpoint is basically like that cross join or the product of those things. So if we're talking about it in a mathematical concept, it's sort of all of those things combined. And that's about as mathematical as I want to get with it because I'm not great at it. But it's basically, yeah, it's the product of those things. So in this case, this is the product of a string, an integer, and a float, which is kind of scary. If you see, like when you see me calling like our C# methods or something that was compiled down to C# inside of here or inside like an F# example, I'm using what's called the Twofold Syntax, right? I have to use parentheses, and I'm passing my arguments, and there's a comma between them. That's called the Twofold Syntax. It looks just like a tuple. It doesn't have the exact same meaning, but if I'm calling something that's an F# construct or a C# construct, that's what that means. Let's see. In spite of common syntax, tuples are not collections. So this is funny. I mentioned earlier that you do not want to use a comma when you mean a semicolon in an array. And why might that be a problem? And that was because if I were to like send this to an array just like that, now I have an array with a single element that's a tuple. And my iterating over it's going to be really disappointing. I'm not going to iterate over these three things and do something. I'm going to iterate over one thing that's a bag of three basically types. But if you don't know that, you might be surprised for a little while. Tuples are basically the reason anytime you see a collection is going to be semicolon, just sort of to be consistent in our syntax. So let's look at some examples of that. Solution Explorer, blah, blah, blah. Functional types, cool. So we talked about unit a little bit. I want to talk about ignore for a second. So you guys have seen me use ignore before. If I do something in a function and but don't use that output in a way, it's going to give me like a warning that says, hey, this is a thing that you might care about. Are you sure that you don't want to do anything with it? Let's be explicit about that and say that we don't care. And so if I go back to like my program.fs and I first, actually this is not a good example because it'll break. But the idea here is I want this return type to actually be unit, not integer. I can pass it to ignore, and that when I pipe it over to ignore, the output of ignore is type unit. So in this case, I actually wrote my own little function here that sort of emulates what ignore does, and it accepts an argument and returns unit, which really underscores the idea that unit is a type, and I can use it in the same way I might use something else in an expression. It feels really weird, though, until you get used to it. And up here, again, it's important to emphasize I'm actually passing in a type or an argument. It's just a type or argument I don't really care about. That's unit. So yeah, let's talk about tuples a little bit more. So this is a tuple, or what's known as a pair, because there's only two arguments to it. And I can do a couple things with it. I can get, if I want to get a single value out of it, I can call FST off of point and get the first argument. Or I can call SND for second to get the second argument. Those two functions, by the way, only work on pairs. I forgot that and tried to do it on something that wasn't a pair and got a fun compiler warning. So yeah, my mouse over it even tells you that, but I wasn't paying attention. And it says it takes in a tuple with two things in it and returns just the second one. So and it even says return the second element of a tuple, or really it should say, I would say pair in that, but then you're worried about idioms, whatever. Another way to get those values out if I don't want to use those, and this is how you would use it on something bigger than a pair, would be to explicitly declare those names and off of the point, or off of that pair. Another way to do that, if let's say I only care about the last argument on something that's like a triplet, and I don't think that's an idiomatic way of saying it, but that's what I'm going to call it. Let's say I just want this last value. I can say z is that third argument where the underscores represent a wildcard or something I don't care about. I'm not going to use this anywhere else. So now I can say I can do something with z at that point. But again, after a little while, if let's say this is a module and I'm using this somewhere else, I've lost a lot of context about what that third argument is. That's not super helpful later. So tuples have a limited, in my view, a limited use case because I really want more context a lot of times. So that's where we come to record types. And record types are one of my very favorite things. They have so many applications in my mind. But this is like creating a class on really one or two lines. I wrapped it strictly because I was worried about screen resolution, blah, blah, blah. But yeah, I just created a person with a first name and a last name. And this compiles down to a class. And everything in here, like I could get the DLL and show you guys the code that comes out of it. We can totally read it and see that it basically is C# with some, it's a little bit verbose because it's trying to make everything immutable and some other things based on whether or not it's a record or whatever the case may be. But yeah, this is a class and I can use it and do stuff with it. The main thing to point out though is the properties on it, I use that term loosely, are immutable, just like everything else. So this is me creating a person, but I didn't have to say, hey, new person, and do like, constructor initialization or anything, or set the properties afterwards. Type inference saves the day again, and I'm able to say, hey, this is my person. Cool. And then if I want to make a change to that person, I can't change it. It's immutable, but I can get a copy of it and change the things I care about. And so and to make that really easy, I wrote a function here that says update the first name, it accepts a person and the new first name. Probably should have been last name, that would make more sense, but whatever. We're in like the witness protection program, and we're not good at it. And I can say, I'm going to update this person with a different first name. So it's going to take everything else that's on that bag of the object or the record and just change this one thing I care about, in this case, the first name. So if I use this, I'm going to get back a new person with a name John. But this part, the last name will still be Abbott in that case. One thing, somebody asked this a couple of weeks ago when I was doing this, and it was a really good question, so I wanted to stop and talk about it. What happens if I have a second record type that's basically identical? Does like duck typing happen, and it's going to look at the structure and make an assumption about what it is, or say, no, this is this? Not exactly. F# is compiled from the top down. So as far as type inference is concerned, person isn't really a thing right now, just person 2, unless I used explicitly. Now, if I were to use a type annotation and say person, then yeah, we're cool. But if I don't, if we're just using type inference at this point, everything's person 2. And I actually didn't realize that until they asked, so that's why I like that question. And I even get a compiler warning down here. This will actually still work. I tried it, but it's going to say we're not really sure what you're expecting here. So yeah, just be careful with that. I'm going to comment that back out. That's weird.
Does adding inline onto that method make the compiler warning go away?
So if I were to use a type annotation here.
No, just the keyword inline before the method.
Uh,
No. Okay.
Yeah, no, the same type.
If you don't define person at all,
mhm.
is that like an anonymous type or is that error?
I would say an error at this point. Anonymous types are actually kind of weird in F#. I actually not even sure how to do them. I've tried before and I was like, the syntax got really ugly, and I was like, if I want to do this,
I don't think they have anonymous types in
I've seen some weird.
Expression, maybe the code is
Right. But yeah, there was a reason why, if you look at my first example here, why if I were doing this in C#, I would use an anonymous type for the optional part of the route, right? And here I did not do that for that specific reason. I actually got the route out and made some changes to it, or added some stuff to it afterwards for that specific reason. Anonymous types are not really a thing. There's some awkward things you can do to kind of get close to that, approximate that, but not quite. Yeah, so that is record types for the most part. Oh, whoa. I'm going to go back to that for a second because I'm almost out of time, but there's like 2 more things I really want to talk about. Functional types, bam. So that was record types. One more important thing with record types, I can actually add like a member method on it, if you will, or a function that is that can do some stuff, which is kind of cool. So again, this is like a class, but it's super compact and immutable. But yeah, I can so I can have a override the toString method because it's an object, and I can add other stuff to it. So I pass it another point, I can get the distance between those 2 points, things like that. I want to talk about discriminated unions for a second, which is another functional type. And at its simplest, it's kind of like enumeration. Like if I, depending on how I declare it, it compiles down to an enumeration. I can use it accordingly. So like I could have an enumeration that's a type that has different, a discriminated union has different cases. And I had a great, I actually need to find it because I found a really great description of what that is. We're going to come back to that. There are discrete cases that are related to each other. It's a composite type made up of individual types. So all of these things are colors. And if the compiler actually turns this into an abstract class with 3 internal classes or classes inside of it. So in this case, for example, I have, again, this compiles down to enumeration, but that's not super interesting. Something like more practical is this idea of a shape. And this is a discriminated union with different union cases. And those are shapes that are circles, triangles, and rectangles. And it's a circle that has a radius, or it could be a triangle that has a base and a height, or it's a rectangle which is going to have a length and a height. But I can do something with each of these. And they all sort of, the expectation is these are all really shapes that I want to, in a lot of cases, I want to operate them on the same way. So one way I think about them, and at least it helps me, is to think about them almost like they're all things that implement an interface. And so I can operate on them in kind of the same way. So if I were to call like get area on them, they'll all give me something back that I expect, but they all might do it in a very different way internally. But I don't really care about what's happening under the hood. So like in this case, I can have, again, just like with record types, I can have like a method that each of them have. So if I have like a circle or a triangle or a rectangle, I can say get area off of it and do something with it. So right here I have like a circle, and it's a type of shape, so I'm going to use like this shape.circle syntax. So whatever the use that actual type is plus the case I care about. And then whatever the constructor is for that, if we want to call it a constructor. And I can do something with it. I can call that method and get the areas back. And so that's discriminated unions. And in 2 minutes, I'm going to give a really bad explanation of pattern matching because I'm almost out of time and I feel really bad about that. So pattern matching is it's not really a functional concept, but it's used in functional programming a lot. Again, I mentioned C# is going to try to get this in 7. There was a rumor very early in C# 6 they were going to get it, but that did not happen. That's okay. So at its essence, pattern matching looks a lot like a switch statement, but it's a lot more powerful than that. But this is really a basic pattern matching example right here. And what I'm saying is I want to do some sort of conditional logic off of this. I want to accept in a code. I want to do something with that and say if it's A, it's awesome, B, it's best, C is whatever. And then last but not least, I have, just like I might with a switch, I have a default case. And that's, again, that wildcard argument, something I don't really care about. It didn't match the things I'm testing for, so we're going to do some sort of default thing. The big difference, though, is if I don't have a default, or if I don't cover every case in my pattern, the compiler is going to get really upset and say, incomplete pattern matches on this expression. For example, the value A may indicate a case not covered by the patterns. So what it's saying here is basically I have an unlimited number of strings after this that I'm not testing for, and I might care about some of those. So it tells me that. That's like one of the cool things about the F# compiler is it's super helpful. And sometimes it's not as much because the warnings can be really frustrating when you're getting started. But I can do some more interesting stuff than these. I'll skip that for now. It's not as helpful. I can do like some pattern matching against a tuple. In this case, like so, I'm matching against a point. We've already talked about kind of what a point is. It's a pair. But what I'm matching against is the structure of something at this point. So in this case, if I get a tuple that is 0, 0, I can do something with it. I can reason about it. I can have a case where I don't really care about what the second argument is, but the first argument, if it's one of these things, greater than or equal to 1, I can say it's on the x-axis, for example, if this was a graph. Or in the other case, I don't really care. Again, I can say it's on the y-axis. Or it's not any of those cases. I can say, hey, this is where it's at on the graph. This syntax is saying this point has x and y. So I have a, which is anything, an object, and then x and y being the integers. And then I have another pattern matching example, but I'm done. I'm a minute over. So I have more code samples and slides about some of this other F# stuff, but I hope that was good for the hour I had. That's it. Thanks.